Welcome back to this new video. In this video, we need to print out an array. Maybe not print out, we need to return an array that will give us all the prime numbers till the number n, including n. For example, take the case of an input 10. So if you give input as 10, then it should give us 2, 3, 5 and 7. These are all prime numbers that are less than or equal to 10. So for the example of 30, it's going to be 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. All the numbers that are less than, right? Less than or equal to the 30, and these are all prime numbers. So basically, we need to just return list of prime numbers that is less than or equal to n. So I'm going to give you a clue on how to solve this naively. In the naive solution of this problem, what we are going to do is we will run the loop from, as usual, from 2 to n. Okay, and then we will check for each number whether it is a prime or not. That's all. Okay, so basically you will run the loop from 2 till n, and then we will check whether each number is a prime number or not. If it is a prime number, then we are going to add that to the list of array. Got it? But remember, we are starting from 2 and not 1. The reason being that 1 is not a prime number. Okay, I hope this clue is sufficient to solve this problem. Try to solve it on your own in the next coding exercise. See you in the solution video. Thank you. Okay, welcome back to the solution video. Let's see how to solve this problem in a naive way. So I'm going to create a new file. This time I'm going to call this as Sieve. You will know in the next video why I'm going to call this as Sieve. But anyway, just ignore it for now. Okay, and the function name is Sieve, and we will get the number as an input. And now inside this, what I will do is like, I'm going to say let output is equal to empty array like usual. And then let's start the for loop from let I is equal to 2, as I said, and this time it's going to run I is less than or equal to num, and then we will increment the I. And inside this, what we will do is like, we will check for each I whether it is a prime or not. So is prime of I. If it is prime, then we will just return output dot push of I. Okay, that's all actually, and at the end we will just return the output. So for till the number n, if it's a prime number, we are just pushing it. Okay, let's add some test cases. So console.log of sieve of 10. So let me copy this, paste it a couple of times, and let's say 25 and then 30. Okay, but remember, we also need to copy the is prime. So let's go to the older file prime.js, and I'm gonna copy this and let's paste it to the 10th one, so probably below this, and let's rename it to is prime. Got it. Now let's try running this program. Okay, it's going to be 10 sieve.js. Yep, as expected, you see we get 2, 3, 5, 7, all are prime numbers, and for 25, 19, 23 and 29 for 30. Cool. So now we get all the prime numbers less than or equal to the number. So see you in the next video with more efficient solution. Okay, bye. Okay, welcome back to the overview of the efficient solution. If you see, the previous video took n times square root of n. Why does that take n times square root of n? See, this loop is running n times, and we all know from the previous videos is prime is going to take square root of n time complexity, and hence the overall time complexity is n times square root of n. But then when we try to use this Sieve of Eratosthenes, this time complexity will be reduced to, time complexity is going to be reduced to big O of n log n. See, the explanation or proof for this is beyond the scope of this video because it involves so many mathematical things. So, but understand, this is going to be far better than the older one because it's nearly going to end, right? Because log n is really slow, meaning log n is really slow to grow. So which means it's kind of like more or less linear, right? Okay, so let's see how to do this using Sieve of Eratosthenes. Yeah, this algorithm name sounds weird, but this is how it is. What we are going to do is like, we are going to create an array of size n plus 1. Okay. And then we are going to fill it everything as true. And now we will loop through from 2 till square root of n, like we did for prime numbers. And we check for each I whether it is a prime. If it is prime, then we will loop through all this prime, and for the factors of this I, right? For example, if it is 2, then from 4. Okay, not 2, not including 2, because 2 is a prime number. So from 4, all the factors. So 4, 6, 8, 10, 12, everything we will set to false. We will do the same for all the numbers till square root of n. Okay, let's get through an example. Let's say we are trying to find all the prime numbers less than or equal to 20. Okay, so let me change the color. Okay, now we know 1 is not a prime number, so you can just ignore it. So we are starting from the loop number 2, right? So when it starts the loop, right, it will start from I into I, which means 2 into 2, which means it starts from 4. So when it comes to 4, you know everything here is set to true. So now when it comes to 4, let's say we are setting it to false. 6 false, 8 false, 10 false. Let me not put this false. If I just strike it out, then it means it is false. Okay, so 12, 14, 16, 18, 20. So the factors of all these things are struck out. Now we increment the I by 1. What is the next one? It's 3. So 3 into 3 is 9. So all the factors of 9, I mean 3. So from 9, all the factors of 3. So 9 is done, 12 is already cut, 15, 18 is already done. Now if we increment 4, right? 4 and 4 times 4 is less than 20. And then if you come and visit this 4, it is already set to false. So we just ignore it. Okay. Now when it comes to 5, it is not less than or equal to 20, right? Because 25 is greater than 20. So now what do we need is like, we come out with this loop, we start one more loop, and then we print out these prime numbers like 2, 3, 5, 7, 11, 13, 17, 19. So how is this working actually? This idea being that for each numbers, we are trying to go through all the factors of it, right? For example, in the case of 2, we went through all the factors starting from 4, and same with 3. So when it comes to 4, all the factors of 4 like 8, 12 are also factors of 2, which means we have already made it as false, and hence we did not go through for false. So at the end, what happens is like, we just have the numbers left, whatever the numbers left as true are the prime numbers. Okay, so we will look through and then print out again. So I hope you got the idea about Sieve of Eratosthenes. So try to solve it on your own. We will see you again in the solution video. Thank you. Welcome back. Hopefully you're able to solve the problem. If not, no worries. Let's try to solve it together now. So let me create a new function Sieve2. Now you know why I gave the name as Sieve, right? It's Sieve of Eratosthenes. Yeah. So Sieve2. Now as usual, let's get the let output is equal to an empty array, and apart from that, we will also create an array which called is prime, and this is going to be of size. So I'm going to use new array method to create it. So to new array of num plus 1. Okay, and then I'm going to fill it as true. Great. Okay, so we have an array that is filled with true as well. Now what we will do is like, we will run a loop. So for, and the loop starts from 2, and then we go till I times I, that is square root of n, right? So I times I is less than or equal to num, and then we do I plus plus, and inside this what we do is like, we first check if of is prime of I. if is prime of I is true, so initially everything is true, right? So initially when we go inside this and I is 2, so is prime of I is as well, which is prime of 2 is true as well. So now we know it is true. So what we will do now, we will start another loop, which is let j, and it starts from I times I, which means in this case from 4. Okay, because I is 2, right, initially to start off with, and it runs till j is less than or equal to num, and then j plus equal to I. So which with each iteration we are jumping by I, which means initially it is jumping by 2. So now inside this, what I'm going to do is like I'm going to set is prime of j is equal to false. What initially we are doing is that we are marking all the values of false, which means we are marking it as false. It means that it is not a prime number. It happens for 3 and then it happens for 4, something like that. Okay, but when it comes to 4, right, this prime of 4 is already false, so it will not be, this loop will not be getting executed. Cool. Now that we have marked all the numbers that are not primes as false, now when we come out of this loop and run another loop that starts from 2 and it runs till I is less than or equal to num and then I plus plus. Now what we do is like we check if is prime of I. If it is true, then we know it is a prime number, right? So output dot push of, so we do output dot push of I, and in the end we can just return this output. Great. So that's all. So now let's try running this program. So sieve of 2, sieve of 2, sieve of 2. Cool. So now if you try to run this program, you see we get the same output. But in fact, we can make this even more concise. Let's see how to do that. So let me copy this and paste it as sieve 3. This time, yeah, this all holds true, but this time what we are going to do is that we will run the loop from 2, but this time not I into I, but I is less than or equal to num and then I plus plus. Now what we are going to do is we will remove the second loop. We know before going, like whenever this is prime of I returns true, then it is a prime number, right? So what I'm going to do is like I'm going to push directly to output array. So output dot push of I. After pushing this prime number, we also set all its factors to false. Okay, that's all actually, to be frank, nothing else. And one question you might have is like, why are we starting from I into I? For example, let's take the case of 3, right? It starts from 9. What about the previous numbers? Are they not, do we need not consider that? The thing is, all the numbers less than 9 in some way are divisible by numbers less than 2. I mean less than 3, sorry. In this case, it's just 2, right? Take the example of 6. 6 is divisible by 2 and then become 9, right? So this is the idea behind it, and hence we can safely start from I into I. Okay, cool. So that's all for this video. See you in the next problem. Thank you.